guys. So let's switch up to Algebra 2. This is a long series that we're going to do. This is actually the core of high school math. And let's follow along the units here. So we're doing Unit 7. This is like exponential models. So we're doing exponential models and we're trying to do the word problems. These are pretty easy.
Right over here is
have a grasp on exponential expressions, then these should be easy for you. So let's first look at the first problem. And it says here, we have this model right here, okay? And the t is the time, and it is asking every day the locust population grows or shrinks by a factor of what? All right. So just assuming this is the original, right? This is what the locust is growing from, population. It's starting from 750, but it will grow exponentially by a factor of this, right? So this is the factor, and it grows, right? It's not shrinking because it's more than 1. If it's less than 1, then there's a different story. Okay, so it grows by a factor of 1.85. Okay, so that's fast forward, right? It grows by a factor of 1.85. And here's the tables right here. You can do the tables, or you can just interpret the model from here, right? Okay, so let's do this one right here. And we have time in years, okay? Time in years. There are some complex models later on that we're gonna see later. And um, if you see right here, the bears, it's talking about the bear population, okay? So it grows from, it shrinks, okay? It shrinks because it's lower than 1, right? So the exponential expression or the exponential graph is drawing that way, right? So let's actually draw this for a second here. If you remember, probably in your algebra or other classes, math classes, you will see that. Okay, so here is growing, right? Here is shrinking, but it all end up with a to the power of 0, which is 1, right? Is this dot right here. Okay, so 1 is shrinking and 1 is growing. Okay, so that's our exponential model. So if you have a 2 to the power of x, then this should be 4, right? If you point it to the 2 and you have negatives, and then it will be shrinking, right? But if you have a shrinking model and you have a positive number here, and it will be closer, you will get closer and closer to 0 because this is a fraction right here, which is 0 point something, which is less than 1, right? You're shrinking right here. If you have, let's say 2, you have a 9 and a 4, which is less than the original factor, right? And you're getting closer to 0, right? But you never touch the 0 because the x-axis is your asymptote. Okay, so that's
yearly rate of change. 0 years since the bear began studying the population. The bear population of the year before. You're multiplying the year before by 2/3.
Right?
So every year the bear population.
Okay. So now we have another model. It's 42 and 1.75. But the question is asking you added to. Okay, added to. So added to means you are not counting the original 1, right? The original 1 has to be taken out. So you add it to 0.75 every time. So it grows around 75% branches are added to the original numbers of branches. So you need to write 75 over here, and you got to select the attitude because it is growing, of course, but we're changing the way we ask the question, right? Okay, attitude. Okay, that's it for this section. Let's moving on to this. Okay, the same
row by 9/5
stories, just more practices. Okay, 1/2. So 1/2, it is asking you about the exponent right now, right? So if you want to halve every second, which is here, no, halve the number of the bacteria for how many seconds? You will halve the number of bacteria. So you want this whole thing to be 1/2, right? So you need to put 5.5 in order for your exponent to be 1, so you get the 1/2 here, right? So this 5.5, okay? Alright, let's try another one. Okay, the sample loses 87.5. So you see right here, it is 87.5. Loses, right? Loses. It means it shrinks by that much, alright? By that much actually, right? So you end up with this. So when you times it, you got the geometric series, right? You times it, and then you want this to be 61.4, so you actually get this number right here, right? So this is 1 minus 87.5, which is fortunate. We have that down, otherwise we will solve the equation. But thankfully, it is actually 1 minus 0.125, that equals to 0.875, right? So that you need 61.4 days over here. It's in days, thankfully, right? Okay, so it should be 61.4. Okay, so the last question is 9 out of 5. Okay, 9 over 5, but you gains, right? When you do the minus, right? Minus 1, you actually gain by that much. Remember, this is same as additive, right? Additive or subtractive, but in this case is additive. Um, so you just minus 1 and you get this number right here. So you actually didn't need to do much because you just put down a 7.3 years, and then the trees will gain that much, right? Will gain the 4 out of 5 to the branches and every 7.3 years. 7.3 years, okay? Now that's it for this exponential models. We'll explain some more later along the way. Okay, thanks for watching. Have a good day.